Hello students, welcome to the GCC physics class. Plus 2 physics, unit number 2, current electricity. In this session, we are going to discuss the following topics. The first one is energy and power in the electrical circuit. The second one is, what is electric cell? What is meant by battery, that we are going to see. In this under this section, the EMF and about the internal resistance we are going to see. The third topic is the combination of the cells. Combination means there are two combinations. One is a series combination and parallel combination. Okay. Now let us go into the first topic. The first topic is energy and power in electrical circuit. See, what is electrical circuit? When a cell is connected across the external device, for simplicity, we can assume a resistance is connected across a cell. Now, this forms the simple electrical circuit. When the battery or the cell is connected, what happens is this is positive terminal, this is negative terminal. Because of this difference in potential, the electron starts moving in the circuit. So of course the electrons will be moving around like this. Due to the movement of the electrons, it carries the energy. For simplicity, let us assume positive charges is moving in this. Of course, this is the direction of current. Always will take the direction of current opposite to the flow of electrons. This is a current direction. That means positive charges are moving like this in the clockwise direction. Now I have assumed the 2 points. A and B are the 2 points across the battery. Similarly, C and D are the points across the external device, that is the resistance here. With the positive charges move from A to B in this circuit, it takes energy or it gains the potential energy from the battery. Then when it is moving, it delivers or giving the potential energy across the resistor. So this happens continuously. As long as the battery is connected, the transfer of energy will be taking place. How fast the energy is transferring determines the power. The power is nothing but the rate at which the electrical potential energy is delivered. That means work done by time. So, when the positive charge is moving across, it gains the energy. Let us assume dq is some amount of charge, v is the potential difference. Now, when this charge is crossing the battery, what happens is, say, it gains the potential energy from the battery. What is the formula for electrical potential energy? This du, small, since we are taking the small charge, the small change in energy is du equal to potential difference into charge, v into dq. Okay, say v is called the potential difference and dq is a small charge. Of course, small charge. We are assuming the positive charge. Okay, so what is the formula for power? Power, see, this is the definition, rate at which the electric potential energy delivered. So power equal to du by dt, the potential energy in a given timing. You substitute, instead of du, what you can substitute? V into dq. So V into dq by dt. Say dq by dt can be written as or taken as I, because I equal to dq, rate of flow of charge. Rate of flow of charge is nothing but the current. So instead of this, so the formula for power is V into this is the power delivered by the battery. V into I. Power delivered to R. Next we are going to calculate power delivered to the resistance. Is the power delivered the battery, power delivered to the resistance. What is the formula for power? P equal to V into I. We know from the Ohm's law, what is the Ohm's law formula? V equal to IR or I equal to V by R. So substitute instead of I, V by R here. So V into V, V square by R. This is one format. Instead of I, you can take or you can substitute for V also. V equal to what? You substitute I into R. So I into I becomes I square R. So there are two formats. So either you can take P equal to V square by R or P equal to I square R. See, this is about the power. The power given, the power delivered by the battery is given to the is given to the resistance or the external agents, external body connected in the circuit. But truly speaking, the entire power is not delivered. Next we are going to see that, because the battery has some resistance. That resistance is known as what? The internal resistance. Okay. So the energy, we have seen the power. Next, energy. What is the formula for energy? Energy is nothing but what? Power into time. The power into time. The charges are carrying the energy. How long it is carrying the energy? If you consider, that is nothing but the electrical energy. Okay. So the duration and the power consumption is nothing but the energy. The unit of power is WATT, watt, or you can say it is joules per second, joule per second. Okay, but commercially, the energy is what? This joules, isn't it? So we are using this kilowatt hour. The commercial units, commercially we are using this kilowatt hour. What is kilowatt hour? Kilo means 1000 watts consumed in 1 hour. The electrical energy consumption is denoted by this larger value, kilowatt hour, the 1000 watts in 1 hour. So 1000 into 1 hour. If you change into seconds, it is 3600. Here 3020. So 36 into 10 power 5 or 3.6 into 10 power 6 joules. Anything you can say. So 1 kilowatt hour is equal to 1 unit or 1 kilowatt hour, kWhr. This is electrical energy. We are using only electrical energy. Okay. The value is 1 kilowatt hour or 1 unit is 3.6 into 10 power 6 joule. Power delivered, எனர்ஜியை பற்றி பார்த்தோம் ஒரு எலக்ட்ரிக்கல் சர்க்யூட்டில். இப்போது ரிலேட்டட் ப்ராப்ளம் ஒன்று. 2 electric bulbs marked 20 watt to 20 volt. The rating is, power rating is 20 watt, voltage rating is 220. And the second bulb rating is 100 watts to 20 volt, are connected in series. They are connected in series to or across the 440 volt supply. See, the question is, which bulb will be fused? Which bulb is fused? Sir, how to find எந்த பல்பு ஃபியூஸ் ஆகும்னு எப்படி நம்ம கண்டுபிடிக்கிறது? ஒன்றும் இல்லை, இந்த வோல்டேஜ் ரேட்டிங்கை விட அதிகமாக இருந்தால், suppose if the voltage rating is the voltage drop is more than the voltage rating, definitely the bulb will be fused. That is a concept. அதுதான் இங்கே பார்க்க போகிறோம். Right, the solution, see here. What is the formula? Power equal to V square by R. எந்த பல்பு ஃபியூஸ் ஆகும்னா, first you have to calculate voltage drop across the first bulb, voltage drop across the second bulb. So to find the voltage drop, நமக்கு என்ன தெரியணும்? முதல்ல current in the circuit தெரியணும். To find the current, what is the total resistance? See here, the two bulbs are connected in series. So first find the resistance of the bulb 1, resistance of the bulb 2. Then you add. Why you should add? Series the problem it is given series, so you add the resistance, you'll get the total resistance, then you find the current. After finding the current, you can find the voltage drop across each and every bulb. Now see here, power equal to V square by R, or this implies R equal to V square by P. In first case, R1 equal to 220. See, the voltage rating is 220 square by 20, that is 220 into 220 by 20, 0 0 cancel. If you cancel 22 and 2, you'll get 1. 220 into 11, you'll get what? 2420 ohm. Since it is a resistance unit is ohm. Okay, the second bulb R2 equal to again V square by R. For this second bulb also the voltage is 220 square by 100 here, because power is 100. So 220 into 220 by 100, 2 zeros will get cancelled. So 22 into 22 is nothing but what? 484. So the resistance of the second bulb is 484. Now you find the total resistance. The combination is series combination. Two bulbs are connected in series, R1 plus R2. So 2420 plus 484, what I will get is the total resistance is 2904 ohm. Then the next step is you have to find the current. Current formula is what? The basic formula is Ohm's law, isn't it? I equal to V by the total resistance. The voltage here V, you should take the series combination is connected across this voltage. You should not take 220. 440 எடுக்கணும். 440 by total resistance போடுங்க. போட்டு இதை roughly calculate பண்ணா எவ்வளோ ஆன்சர் வரும்னா 15 something 151 அவ்வளோதான் ஆம்பியர். யூனிட் இஸ் ஆம்பியர். 151. So this is the current in the circuit. See, both the bulbs are connected in series. Same current will pass through. Same current. Next, the voltage drop across the first bulb. So V1 equal to I into R1. So what is I? 0. This is 0.151 into R1. R1 value is what? 2420. Multiply. If you multiply these two factors, you will be getting nearly equal to 367. 366 point something. You can approximate it to 367 volt. Then the voltage drop across the second bulb. So V2 equal to I into R2. I is 0.151 into R2 value. You substitute R2 value 484, 73 volt. இப்போ பாருங்க, voltage drop across when they are connected in series across this 440 volt, இது maximum withstand பண்ணுறது 220 volt தான். The voltage drop across the first bulb என்ன வருது? 367, which is more than this bulb. Fuse ஆகிடும். Second bulb fuse ஆகாது. Why? Because it is less than the voltage rating. 220 விட குறைவாக இருக்கிறதுனால second bulb fuse ஆகாது. First bulb it will get fused. Okay? Yes. The next second, we are going to move into the second topic, that is electric cell and the battery. See, what is electric cell? It's a simple device which converts chemical energy to electrical energy. Suppose definition கேட்டாங்கன்னா இதுதான் எழுதணும். Chemical energy electrical energy மாற்றக்கூடிய டிவைஸ்க்கு பேர் electrical cell. சரி, அது என்ன battery? If all the cells, if number of cells are connected together, it forms a battery. That is the difference between the cell and the battery. Okay. Same, the simple cell. You can see here, there is a simple cell. In a container, the liquid or the acid is taken. It is called the electrolyte. In the electrolyte, two electrodes are dipped. Say one is zinc electrode, another is say carbon electrode or whatever. When it is, the chemical reactions occurs. Because of the chemical reaction, the charges are accumulated in the two electrodes. The one is positive. This is the positive terminal. The electrons are gained by this. So this electrode is negative terminal. Suppose when the cell is connected to the external device, what happens is electrons will flow from the negative terminal to the positive terminal. So because of this potential difference, see, what happens is electrons will move from negative terminal to positive terminal. Okay, cells. See, actually the cell or the battery gives the EMF. So what is the meaning of EMF? EMF means electromotive force. Since a force வரதுனால எல்லாருமே என்ன, it is not a force, it is a deriving agency to maintain the potential difference. It is a deriving agency to maintain that. சிம்பிளாக என்ன ஞாபகம் வச்சுக்கலாம்னா, அந்த பேட்டரி ஆர் த செல் கனெக்ட் பண்ணாத முன்னாடி, when it is not connected to the external circuit, அந்த எக்ஸ்டர்னல் சர்க்யூட்டில் இல்லாத பொழுது no current flows through the external circuit. அப்போ மெஷர் பண்ணக்கூடிய பொட்டன்ஷியல் டிஃப்ரென்ஸை you can say it is an electromotive force. This electromotive force is denoted by the symbol, say, இப்படி இதான் சிம்பிள். ஸோ ஆக்சுவலாக என்ன, இதை எப்படி படிக்கணும்னா சைன்னு படிக்கணும். எப்படி படிக்கணும்? சைன்னு படிக்கணும். இந்த இ மாதிரியே இருக்குது, கொஞ்சம் பெண்ட் பண்ணி போடணும். ஸோ அப்போ இஎம்எஃப்னா என்ன? இட் இஸ் நாட் ஏ ஃபோர்ஸ்ன்னு சொல்லிட்டோம். அது தவறுதெல்லாம் நம்ம சொல்லக்கூடியது எலக்ட்ரோமோட்டிவ் ஃபோர்ஸ். ஸோ இட் இஸ் த ஏஜென்சி டு மெயின்டைன் த பொட்டன்ஷியல் டிஃபரன்ஸ் ஆல்வேஸ். ஓகே, திஸ் இஸ் த டெஃபினேஷன். அமௌண்ட் ஆஃப் ஒர்க் a cell or a battery does to move certain amount of charges in when you are connecting to the external circuit, some amount of work is done by the this potential difference. So the charges are made to move by this external agency. That is called what? This amount of that is called EMF. EMF is the amount of work a cell or battery does to move the certain amount of charges. Okay, suppose an ideal cell has the EMF and the voltage or the potential remains same. But practically ஒரு செல் பார்க்கும் பொழுது இஎம்எஃப்பும் பொட்டன்ஷியல் டிஃப்ரென்ஸும் சேம் தான். பட் என்ன அப்படின்னா ஒன்லி ஃபார் த ஐடியல். அது என்ன, வாட் இஸ் த மீனிங் ஆஃப் ஐடியல் பேட்டரி? ஐடியல் மீன்ஸ் விச் cannot be realized in practice. எதுவுமே மிஷின்ஸில் எதுவுமே ஐடியல் கிடையாது இல்லையா? there may be certain wastages. அது என்ன சொல்கிறாங்கன்னா, this cell or a battery has certain resistance. When the charges are moving around the external circuits, during the close ஆகும்போது, closed circuitல வரும் பொழுது, the charges are experiencing some opposing force by the electrode as well as by electrolytes. Some amount of opposing force is given by the battery itself. That is known as the internal resistance. And the internal resistance இருக்கிறதுனால பொட்டன்ஷியல், த எக்ஸ்டர்னலாக கனெக்ட் பண்ணும்பொழுது இருக்கக்கூடிய பொட்டன்ஷியல் டிஃப்ரென்ஸ் உள்ள ஆக்சுவலாக இருக்கக்கூடிய இஎம்எஃப்பை விட குறைவாக இருக்கும். சப்போஸ் இன்டர்னல் ரெசிஸ்டன்ஸே இல்லைன்னு வச்சுக்கோங்களேன். அப்போது இன்டர்னல் ரெசிஸ்டன்ஸே இல்லைன்னா உங்களுக்கு ரெண்டுமே ஈக்குவலாக இருக்கும். கனெக்ட் பண்ணாத, அதான் இங்கே பாருங்கள், நோ கரண்ட் ஃப்ளோஸ் இன் த சர்க்யூட். அப்படின்னா என்ன அர்த்தம்? த பேட்டரி இஸ் நாட் கனெக்டட் டைரக்ட்லி. இஃப் யூ ஆர் மெஷரிங் the potential difference, that is nothing but the EMF. But when it is connected to the external circuit, ஒரு பேட்டரி வந்து எங்கன்னா ஒரு பல்பில் கனெக்ட் பண்ணியிருக்குன்னா, பல்ப் இஸ் அன் எக்ஸ்டர்னல் சர்க்யூட். அது வழியாக ஃப்ளோ ஆகிட்டு வரும்பொழுது அது இட் இஸ் நாட் செட் டு பி EMF, இட் இஸ் த வோல்டேஜ். ஓகேவா? ஸோ அதுதான் இங்கே சொல்லுது. ஸோ ஐடியல் பேட்டரிக்கு ரெண்டுமே ஈக்குவலாக இருக்கும், யூ கேன் சே. பட் ப்ராக்டிக்கல் பேட்டரிக்கு EMF ஆர் பொட்டன்ஷியல் டிஃப்ரென்ஸ் இஸ் ஆல்வேஸ் lesser than the EMF. Okay, the voltage or the potential difference is always lesser than the EMF because of what? Internal resistance. Okay, internal resistance may increase. எதனால் இன்க்ரீஸ் ஆகலான்னு பார்த்தீங்கன்னா, டியூ டு த ஏஜிங். த காம்போனன்ட்ஸ் யூஸ் பண்ணுறோம் இல்லையா, அது ஏஜ் ஆக ஆக இன்டர்னல் ரெசிஸ்டன்ஸ் கேன் ஆல்சோ பி increased. அப்போ increase ஆகும்பொழுது ஆட்டோமேட்டிக்காக என்ன ஆகும்னா the flow of charges will decrease. We can say current decreases. Okay, this is about the electric cell and the battery. Now the internal resistance ன்னு சொன்னோம். Internal resistance என்னது? The resistance offered by the cell or the battery, that is given by the electrodes or electrolytes. அது சொன்னோம். அதை இங்கே பார்க்க போகிறோம். Internal resistance is denoted by the symbol R. See the two circuits போட்டு வச்சுருக்கேன். This is a very simple electric circuit. A cell having the EMF psi is connected or is there. It is not connected to any external circuit. Just we are measuring the voltage across the battery because no current is flowing. It is not connected to external circuit. அப்படி மெஷர் பண்ணோம்னா this voltmeter measures the EMF. ஏன் this voltmeter specifications என்னன்னா high resistance. Since a high resistance voltmeter is connected, it won't draw any current. அப்போ அதில் இருக்கக்கூடியது அப்படியே வந்து potential difference it will show. Okay, so what is this? This is nothing but the internal resistance by the cell or battery. Okay, this is the first one. Next, let us assume the battery or the cell is connected across the external resistance. This is capital R is the external resistance. What is the potential across R? A voltmeter is connected. So what is the potential drop across R? What is the formula? Voltage, once again you have to use the Ohm's law. Ohm's law பார்க்கணும். V equal to IR. That is the formula. Okay, so I is the current from the battery, R is an external resistance. Okay, actually the psi is an EMF. When it is coming across this internal resistance, the potential difference always lesser than the EMF. முன்னாடியே சொல்லியிருக்கிறோம் இல்லையா, EMF விட. அப்போ என்ன ஆகுது? There is an voltage drop across due to the internal resistance also. சர்க்யூட்டில் இங்கே தனியாக எடுத்து காமிச்சிருக்கோம். அது ஆக்சுவலாக it is inside. Okay, so voltage drop across. அப்போது the potential difference equal to EMF minus potential due to the internal resistance. I into small r, where I is the current. So IR left hand side கொண்டு வாங்க, the V is taken to the right hand side. What you will get? IR equal to psi minus V ன்னு கிடைக்கும். So this is equation 1. Equation 2, what is the heading here? Determination of internal resistance, that is R. So R கண்டுபிடிக்கிறோம். Equation 2 divided by equation 1. So IR divided by this IR, capital IR, equal to psi minus V by V. I cancels, this I cancels, R by R equal to psi minus V by V. Small r equal to, you take this R to the right hand side, R into psi minus V by V. This is the formula for what? Internal resistance. Using this formula, the internal resistance can be calculated. Okay, so this is about the internal resistance determination. Now let us see the formula based on this the internal resistance. See, this is now let us see the problem based on the internal resistance formula. Small r equal to R into psi minus V by V in V by V. Okay, see the problem. A battery has an EMF of 12 volt. So psi equal to 12 volt connected to a resistor 3 volt. Capital R equal to, so psi equal to 12 volt, R equal to 3 ohm. The current in the circuit I equal to 3.93 amp. These are the data given. So என்ன கேட்குறாங்க? Calculate four divisions are there. First, terminal voltage. The second one, internal resistance, power delivered by the battery, power delivered to the resistor. So the first one பாருங்க, what is the terminal voltage அப்படின்னு பார்க்கும் பொழுது formula is I into R, direct substitution. I வந்து 3.93 into R வந்து 3 multiply பண்ணிங்கன்னா இது கிடைக்கும் terminal voltage. First one is over. The second one is internal resistance of the battery you have to find. Internal resistance formula இப்போ தானே பார்த்தோம். Small r equal to என்னது R into psi minus V by V அவ்வளோதான். Substitute 3 into 12 minus V. V in the V. இதுதான் பாருங்க 11.79 by 11.79. If you simplify this, you will get the value R equal to 0.05 ohm. This is the internal resistance of the given battery. The third one is power delivered by the battery. Power delivered by the battery or the power rating mentioned in the battery. So power is என்ன formula? Current into voltage. ஓகேவா இங்கே பேட்டரின்னு சொன்னதுனால the psi you have to use EMF எடுக்கணும் பொட்டன்ஷியல் டிஃபரன்ஸ் கிடையாது EMF ஸோ அப்போ I into psi ஸோ வாட் இஸ் த I வேல்யூ 3.93 into psi வேல்யூ அவங்க கொடுத்துருக்க EMF வேல்யூ எடுத்து போட்டுக்காங்க ஸோ the power delivered or the power rating of the battery is what the 47.1 Wன்னு போட்டிருக்கேன் W means watt unit of power ஏற்கனவே பார்த்தோம் unit of power is what watt okay the fourth question is power delivered to the resistor so power delivered to the resistor na என்ன formula முன்னாடியே பார்த்தோம் இல்லையா I square R sir V square R is also there so அது இங்க V is not mentioned correct so you take this formula I square R so 3.93 square into 3 if you simplify this what you will be getting is 46.3 watt பாருங்க is the power delivered by the battery அப்போ குறையுது power delivered to the resistance மீதி power என்ன ஆச்சு sir the remaining power is wasted because of the internal resistance the internal resistance நால certain power is wasted so only there is a decrease பாருங்க power rating by the battery வந்து 47.1 watt இருக்கு இது வந்து பாத்தீங்கன்னா 46.3 because of the internal resistance okay the last topic is the combination of cells அப்போ cells எல்லாத்தையுமே combine பண்ணி பார்க்கும் பொழுது this is a combination there are two types of combination one is series combination the other one is parallel combination now let us discuss about the series combination what happens when the cells are connected in series okay cells எல்லாம் combine பண்ணோம்னா it forms a battery ன்னு ஏற்கனவே பார்த்திருக்கோம் ஓகேவா now the cells which are connected in series now what is the meaning of series connection so cell means it consists of a positive terminal the bigger line represents positive this is a symbol for cell the smaller line represents negative cell the negative terminal of the first cell is connected to the positive terminal of the second cell the negative terminal of the second cell is connected to the positive terminal of the third cell the free end positive terminal of the first cell and the negative terminal of the last one is the free end is connected across the external object that is external resistance R okay this is known as the series connection so like continuous one to one okay now let us assume psi is the EMF of each and every battery small r is the internal resistance of each cell okay so because of this connection there is a flow of current through the circuit or through the resistance external resistance okay now we are going to calculate the what is the current in the circuit okay what is the formula for current the voltage by resistance what is the total EMF by total resistance after finding that if you substitute you'll get the formula that is a formula for current okay so since all the battery all the cells are connected in series the total EMF is n times the individual cell EMF n psi okay then what is the total resistance in this circuit electrical circuit So all the internal resistance are connected in series, then this external resistance also in series, R plus R plus R. Suppose if you assume n cells are there, nr plus this resistance, so this is the total resistance. So current in the circuit is total EMF by total resistance. So n psi by nr plus R. So this is the formula for current. Now let us consider the case 1. Suppose if the internal resistance is very very less than the external resistance. The internal resistance of a cell is less. If R is very less, when you compare with the capital R, this term can be neglected. Okay, only R will be coming. N psi by R only comes. N times, this is the current delivered, current due to the single cell alone. So the current is increasing or multiplying, you can see. See the case number 2. Suppose if you assume the internal resistance of each and every cell is very much greater than the external resistance. In this case, what happens is R is omitted, the NR cannot be omitted. So N psi by NR, say N gets cancelled. So psi by R, this is nothing but the single cell current. So which one is advantageous? Say if the internal resistance of a cell is very much lesser than say you will get more current. So in the series combination, see you have to see the cell should be, if the internal resistance is very much less, so you have to connect it in the series connection. Now let us see about the cells which are in the parallel connection. See what is parallel connection? Suppose for example I have taken the 3 cells. All the positive terminals are connected to the point, certain point, a single point A. All the negative terminals are connected to the point B. Then between A and B the external resistance R is connected. Okay, if positive and positive are connected together and negative are connected together, then it is called the parallel connection. So as usual, psi is the EMF of all the cells, individual cells. Smaller is the internal resistance of each and every cell. So since it is all are in parallel, same value will occur. So in the first case, n psi. Here the total EMF is what? The psi only, this psi. Okay. Then the equivalent resistance or the total resistance in the circuit we have to calculate. The same, in the previous case, all are in series. So we have directly added. But in this case, parallel combination of resistance use pannanom. Parallel combination 1 by R equivalent. See here I have written the internal resistance alone. R equivalent equal to 1 by R plus 1 by R plus 1 by R. Suppose if n cells are there, so n, so dot dot. So n times by R, n by R. Say 1 by, you have to take the reciprocal. So R equivalent is R by n. N by R becomes R by n. This is the equivalent resistance of the internal resistance. So what is the total resistance? Sir, external resistance you include panano. Total resistance is what? R by n plus R. Okay. What is the current? Next you have to find the current. Current equal to EMF by resistance. EMF value is what? Psi by R by n plus R. You take LCM n. R plus nr by n, that n will go to the numerator. So this formula becomes I equal to n psi by R plus nr. This is the formula for current in the circuit when the cells are connected in parallel. As usual, we have to discuss, analyze case number 1. Suppose if you assume the internal resistance is very very less than the external resistance. So if this is compared to this value, this is neglected. So என்ன கிடைக்கும் உங்களுக்கு n psi by nr னு கிடைக்கும். n cancels. So it is nothing but what? Psi by r. So the current in this, suppose internal resistance குறைவா இருந்ததுன்னா parallel combinationல கொடுத்தோம்னா current in the circuit என்ன இருக்குன்னா it is equivalent to single cell current தான் இருக்கும். That is the answer we are getting. So case number 2 பாருங்க. Suppose internal resistance is more or is very much greater than capital R external resistance. Internal resistance is high value. அப்படின்னு வரும் பொழுது என்ன கிடைக்கும்னீங்கன்னா I equal to N psi by NR can be neglected. Small r வரும். அப்போ psi by R is the current given by the single cell. So N times current given by the single cell. அப்போ this is advantage. அப்போ ஒரு internal resistance பொறுத்து தான் we have to decide whether it should be connected in series or in parallel. Say if the internal resistance is very much less, series combination is best. If the internal resistance is greater, we have to connect only in the parallel way. This is a conclusion we are getting from this formula. Okay, so far we have discussed about all the three, that is by energy and power in the electrical circuit. Then the second one is what is cell. Cell is an electrical it is a device which converts chemical energy to electrical energy. Then combination of cells. ஸோ காம்பினேஷன் ஆஃப் செல்ஸில் எந்த காம்பினேஷன் நம்ம எப்போ யூஸ் பண்ணலாம் அப்படிங்கிறத பார்த்தோம். ப்ராப்ளம் இஸ் கிவன், ரெண்டு வெரி சிம்பிள் ப்ராப்ளம், டைரக்ட் சப்ஸ்டியூஷன். யூ கேன் டூ இட். இஃப் யூ ஹாவ் எனி டவுட் we can see it in the next class. Okay students, thank you, see you.